Hello friends, today I will discuss about restricted earth fault relay in case of star winding of a transformer. Now the diagram shows how the REF relay is connection for star side of a transformer. Here there are four cities, three cities taken from the three phases of the transformer, that is red phase, yellow phase and blue phase. Another city is included, that is from that is called neutral city or N cities. Now the polarity of the three phase transformer should be same, and also for NCT the P1 should be connected in the earth side and P2 should be connected in the transformer neutral side. And for phase cities of the transformer, the P1 should be connected in the bus side and P2 should be connected in the transformer side for all the phases. If phase bushing city is available, then this REF relay formation is taken from the bushing city in terminal. Now for secondary side, all the S1 terminal for red phase, yellow phase and blue phase are sorted together, and also NCTs of secondary, that is S1 terminal, sorted together and fed to one end of a REF relay, and all the S2 terminal of red phase, yellow phase and blue phase and NCTs S2 terminal sorted together and fed to another end of the relay. Now why it is called REF relay or restricted earth fault relay? Because if fault occur within these cities and between N cities, then only relay will operate, otherwise relay will not operate. This is why it is called restricted earth fault relay, that is the zone is restricted for this relay. Now the condition for REF relay is the ratio of the all the four cities should be same, that is if ratio of these cities is 400/1, R phase cities is 400/1, then Y phase, blue phase and the N city should be 400/1. And also the knee point voltage for all the cities should be same, and I already discussed that polarity should be same for all the city and the N cities. P1 should be connected in the R side and P2 should be connected in the neutral of the transformer. This is how REF relay formation is done. Now I will check how the REF relay act when a through fault occur, that is fault occur in the outside of this restricted zone, and how the REF relay act when fault occur in the inside zone of the transformer. Now a through fault occur in the B phase, that is through fault means outside the zone of the restricted zone. Here through fault occur just after the CT in the B phase. Then we'll see how the current will impact in the REF relay. Now for a CT, if current flows in the primary side from a direction from P2 to P1, then in the secondary side the direction of the current should be in from S1 to S2. Again, if the current flows in the primary side from P1 to P2 direction, then in the secondary side the current will flow from S2 to S1 terminal. Now fault occur in the B phase to earth. This current circulate via neutral earth of the transformer, and it will flow via NCT from a direction from P1 to P2 terminal, and via blue phase of the star winding of the transformer, and from the blue phase CT from a direction from P2 to P1 to the fault point. Now for NCT, as the direction of the current in the primary side is from P1 to P2 direction, then in the secondary side the direction of the current should be from S2 to S1 terminal, and this current will flow towards the relay. And in the blue phase CT, as the direction of the current from P2 to P1 terminal, in the secondary side of the blue phase CT, the direction of the current should be from S1 to S2. Now this current will flow towards the relay. Now, as this direction of the current and this direction of the current, that is NCT direction of the current and blue phase CT direction of the current, opposite in nature, but the magnitude of the current is same, the net current flow in the relay is 0. That is why under through fault condition the relay will not operate. Now we'll check how relay will act when a fault occur in the in zone of the restricted zone. Now if a fault occur in the in zone of the restricted zone of the RF relay, that is fault occur in the blue phase to earth, but the fault point is different. Here this fault current will be supplied from this end and also from this end. This fault current enter the earth point of the NCT or neutral point of the transformer of the star winding, and for the NCT the direction of the current is from P1 to P2, and this current will flow towards the B phase winding and towards the fault point. And for phase CTs for blue phase, the fault current will be supplied from the 132 kV bus towards the direction from P1 to P2 direction from blue phase CT and towards the fault point. Here the direction of the current for NCT is from P1 to P2, and that is why in the secondary side of the NCT the direction of the current is from S2 to S1, and for blue phase phase CT the direction of the current is now from P1 to P2. That is for P1 to P2 direction current in the primary side, the direction of the current in the secondary side is from S2 to S1. That is both the current direction from NCT and for blue phase cities is now same. Therefore the secondary side both the direction of the current is same, and these two current will be additive in nature, and that is why relay will operate and it will send a trip signal to the circuit breaker associated with the transformer, and it will clear the fault. Now consider a situation when CT polarity of one of the phase CT is wrongly connected, or CT polarity is reversed. Here the blue phase CT is connected wrongly, that is P2 of the primary side of the blue phase CT is connected towards the bus side, and P1 is connected towards the transformer side. Rest of the all other connection is remain same. Now under load condition, we will consider how the relay acts under normal load condition. Now relay setting is 0.1 ampere. 0.1 ampere secondary current flow in the relay will operate. Now consider for all the secondary phase current is I under normal load condition. That is IR in the secondary side of the red phase is I, and for yellow phase it is again I, and for blue phase it is I, but direction of the current for red phase is from S1 to S2, for yellow phase is again S1 to S2, but for blue phase, as the direction of the current primary side is from P1 to P2, the direction of the current from secondary terminal from S2 to S1. Now under normal condition, the relay current, that is IR plus IY plus IB is equal to 0, as it is a vector sum of all the balance load current. But since the blue phase CT is polarity is reverse, so IR plus IY is equal to minus IB plus IB. Now IB is minus I, so here the relay current is minus 2I. So if I is equal to 0.05 ampere, the relay current will be 2 into 0.05, that is 0.1 ampere, and lead to relay to operate. For example, if the CT ratio is 600 by 1, and it is a 10 MVA transformer of 33 by 11 kV, and 11 kV side is star connected. Then if 30 ampere current flow under balanced load condition, then the relay will operate. So if one of the phase city is wrongly connected, polarity of the city is wrongly connected, then under normal load condition the REF relay will operate. Now the CT polarity or in CT is reverse, that is P2 in the primary side is connected to the earth and P1 is connected to the neutral of the star side of the transformer. Now under normal condition, normal load condition, there will be no problem as the balanced load flow under all the three phases, the sum of all the three current is 0, and there will be no current through the NCT, and that is why the relay current is 0 under normal balanced load condition. But under through fault condition, that is fault occur in the outside zone of the restricted earth fault zone, occur in the through fault condition from B phase to earth fault. At this point the fault current will enter the earth and it will flow towards the earth of the neutral of the star winding, and in the NCT the direction of the current is from P2 to P1. This current flow towards the winding of the blue phase, and from blue phase to the fault point via phase city of blue phase. In the blue phase city, the direction of the current is from P2 to P1. That is, direction of the current for NCT and blue phase city is same. Similarly, in the secondary side, the direction of the current should be from S1 to S2, and for NCT from S1 to S2. These two current will be in additive in nature, and this is why relay will operate under through fault condition, leading to maloperation of the relay. That is, if NCT polarity is wrongly connected or get reverse, then under through fault condition the relay will operate. But normal condition there will be no maloperation.